In this video, let's review how to use pointers as a function parameters. So we have defined an array D as follows with the initial values. Then let's call a function named show. And then let's give a name of the array. Then to define this function, we have learned in earlier chapter that a name of the array is a passed, then function should parameter should be the array definition. So you can receive an array name by defining variable this way, that you define type of the array and then name and then empty square bracket. And using that, now you have received the array name D into variable array. Once the variable is initialized as array name, you can use this variable as if array name, meaning that you can have access to the elements of the array using the variable. So I want to display all the values, so size, so we should receive how many elements are in the array as well. So let's pass that info as a second parameter. Then as I increment the counter variable I, now I can display the value using the variable which was assigned by the name of the array. So we have learned this one, and before you use the function, you have to either define or give a prototype. So we have to give a prototype of the function. So let's compile the program, and then as we run it, we see that the function is called and the contents of the array is passed. We can do same thing but using the concept of the pointer. So here the name of the array in C++, name of the array is the same as the address of first element. So that's the C++ convention or syntax meaning as the array is defined. So which means as I pass the name of the array, which is the same as address of the first element. So when you send the address, you can receive the value, which is address, in a variable. Then the variable has to be a pointer. So let's define another variable, another function. Let's name it as show p. Then if you give the name of the array, then that is the address of the first element. So we can define show p function, since the first parameter is address of a first element. The first element is double type, so we can declare a double pointer, then like this. So here this is actually you are declaring a pointer but with a different syntax. Now since we understand that these the address of the first element, so we can receive the address value in pointer variable p. Now you can display the contents of the array using pointer p. So if I do loop again, so I can print the value where the pointer is pointing to. So we have a dereference operator star there. Then using star, we loop 5 times, but the very first time currently p is pointing to the first element. So let me draw a picture for that. So array D we have 1, 2, 3, 4, 5 elements, index 0, 1, 2, 3, 4. Then we have a value like this. Then when the show p function is called, we define and create the pointer p at the very beginning. Since d was provided, d is address of the first element. So in p we have address of first element of the array is stored. So if I do star p, then we go to this address, then we go over here, and then we print the value. So you can print all the values in the array using pointer arithmetic. Pointer arithmetic is that if you add an integer to the pointer, then you do not simply increment or add the address value by I, but you are moving to the next element. That's a pointer arithmetic. So when I is 0, you do p plus 0, so it's referring to the first element. Now in I is 1, p is now p plus I is now pointing to the second element in the array and the like. So using pointer arithmetic, you can have access to all the elements in the array. So let's compile this program. Then the prototype of show p is a double pointer is the first parameter. Now let's compile the program, then run it. We get the same result. Now we are using show p, using pointer we do so. In this show p function, let's take a look at one interesting thing. So if you forgot to give a parenthesis here, then meaning of this part is that we do this part first. So when we have a indirect operator and then addition operator, the dereference or indirect operator is on higher precedence. So you evaluate star operator first and then do addition. So if you do loop like that, what you get is p is address of first element. You always get the value of a first element, which is 1.1. Then add I onto that. That's what's happening there. So you need to be careful about this one. So if I compile this program and then run it, as you can see, what you get is from 1.1, you just add 1 by 1 to all the elements. So that is not correct. So to have access to all the elements, be sure to give parentheses here. So we do the pointer arithmetic first and then have access to the address. So using pointer, you can do some interesting thing, meaning that function could return only one value. You cannot return more than one. But if you want to design a function, by calling the function you want to get more than one value, then we can use a pointer for that purpose. For example, I want to design a function called the max min. There I provide the three numbers, 3, 10, 1. Then I want to get the smallest number and the largest number out of 3. Then I want to receive the result n, m, and n like that. So here those threes are input to the function call, and then the function computes or finds smallest and the largest, and then I want to receive the value here. Then if you define this function, you may not get something as you desire. So I define nmn, then I want to receive the value. So say max is m, min is n, and the like. So let's try to define max-min function. So prototype void max min, we pass three values, then we want to receive a maximum value and minimum value like this. So let's define max min function. So a, b, c are provided, then we want to return result 1, which is a maximum, result 2, which is a minimum, and the like. Then the algorithm is let's assume that a is the maximum value. Then if b is greater than r1, then maximum should be b. If c is greater than current maximum, then maximum should be c. Similarly, let's assume a is the smallest, then if b is smaller than r2, then r2 should be b. If c is smaller than r2, then r2 should be c, and the like. So we have stored r1 and maximum of 3, r2 minimum of the 3. Then if you run this program, let's say just for testing purpose, let's give assign m is -1, n is -1 as well, and then as you compile the program and then run it, minimum maximum is a -1, even if we stored some value in R1 and R2. If you remember, this program does not work because we have a pass by value. Just quick review that in the main function we have defined two variables m and n. And then when you call the function, the value is passed, not the variable itself. So value of 3, 10, 1 are passed and stored or copied into ABC parameter in this function. When you call the function with the m and the n, m and the n variables are not passed, but the value in the variable, currently it's -1, -1. So -1 is assigned in those parameters. So when a function called, the function execution jumps into the function definition. So at that moment, in that area, the function creates all of its own variables. So here A, B, C, R1, R2, those variables are created within this function's scope. And then in this code, within the function, all of the things you do is on these variables. So what we will do with this 3, 10, 1 value, R1 will get 10 out of this logic, and then R2 will get 1 out of this logic. And then the function returns where it was called, then see out when you have access to m. Now everything from max function is now gone. It's all returned back to the main. So m is referring to -1, n is referring to the -1. So we don't get the result what we desire. So to fix this problem, what you need to pass is not a copy of the value. You need to pass the address of the variable. If you pass address of the variable, then you can have access to the variable indirectly using star operator. So since address of m1, m and n are passed, so when you define function, you are receiving address. Of course, I need to modify the prototype. So fourth one is address, the last one is address. So when address is passed, then you can have access to that with a indirect operator or dereference. So if I use dereference for each of those pointers. Here is the pointer, 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 pointer. Then whatever you write into is actually referring to m and m. So let me draw the picture for that. So when function is called, at this moment the variable m and n was defined, we initialized with that. Now function is called. Then what you get in R1 is address of m, and R2 is address of n. So when I do star R1, I'm moving to a variable m. So address of m star means I go there. So what you store in star R1 is actually in m you are storing a. So a you are storing there, 3 is stored. And then b and then star R1, b is 10, 10 and star R1, 3 are compared. So now it's updated with a 10. The C and star R1, C is a 1, so it's not updated. So similarly for star R2 operation, what you actually use is a variable n in main function because R2 is holding address of it. So by passing address and then receiving the value through pointer and then using indirect or dereference operator, you can do something on the original variable in the main function. So this way you can get the function results from the function more than one. Then you can just do something like this. By passing the address of the variable, you can have the function write into the variable directly, and then you can receive the result when it is done. So here in this program, is we compile and run, now minimum and maximum is correctly computed. So using the pointer as a function parameter, you can have access to the variable from within the function call. So that is a indirect operation. You can do that.